I am Anil Kumar, and now we will look into another exception to the rules of rational functions. Rational functions have restrictions in range. Is this statement always true? Think about it. There are so many times when the rational functions may not have restrictions on the range. Let us consider two functions. Let us say f of x equals to x plus 1 over x minus 1 and g of x equals to x over x squared minus 1. And let's draw their graph. So if I draw this graph for f of x, then what do we get? We'll get a vertical asymptote at x equals to 1. And if x is 0, then the value of y-intercept will be minus 1. So it goes through minus 1. So the graph will be kind of like this. And on this side, it will be kind of like this, right? We are not getting into details of this, but somehow like this, right? So what you observe here is that we have a horizontal asymptote, which is y equals to 0. That leads to restrictions in range, right? And so we can write that the range of the function is y belongs to real numbers where y is not equal to 0. Perfect. Likewise, in most of the rational functions, we will have a restriction, and that restriction on the range is commonly seen. But there are many examples where this restriction may not be there. Let's take up this example. So in this particular case, we have x over x squared minus 1. Degree of numerator is less than the degree of denominator. So in this case, we do have a horizontal asymptote just as we had here, right? So we have a horizontal asymptote just as we have here, which is y equals to 0. So x-axis, which is y equals to 0, is the horizontal asymptote. We have two vertical asymptotes, one at plus 1 and one at minus 1. So let me draw the one at minus 1 first and then at plus 1, right? Now if you sketch this graph, what will you find? If x is 0, what is g of 0? It will be 0, right? So actually you have a point on the horizontal asymptote itself. Do you see that? Because of that, there is no restriction as we had in the previous case. So if you graph it, it will be kind of like this. So I'll leave this exercise for you to figure out how to graph this kind of a function. But as you can see, here also we do have horizontal asymptote, and the horizontal asymptote is y equals to 0. However, the range for this function is what? Range for this function is y belongs to real numbers, and there is no so in this case what you find is that the range has no restriction at all, right? There could be many examples like this. I encourage you to look forward to some of these. Many of them which will have oblique asymptote may not have restriction, since the oblique asymptote takes away the case of horizontal asymptote, right? Restrictions in the range are normally led by the horizontal asymptotes, but horizontal asymptotes can be crossed by the graph of the function. That is important to understand and realize. And because of that, we will have many rational functions which will have no restrictions in their range. I hope you understand and appreciate it. Thank you.